Well, hey there, everybody. Welcome back as we finish the course online here. Our next topic as we continue to work through geometry topics is the topic of area. So I would recommend that you have your gold conversion sheet out. We're going to add some formulas to that. If you don't have that, if maybe it's locked up at school, just take a new sheet of paper and form a new formula sheet for the rest of our topics here. Here we go. Okay, so area. Area is the measure of the space inside the perimeter. If you remember from our work before this disruption, perimeter is the distance around the outside of a shape, whereas area is a measure of the space inside of a shape. And so each shape has its own way of finding areas, and the simplest shape to find the area of is a rectangle. And for a rectangle, all we need to do is multiply length times width. So let's take a look at a pretty practical problem that some of you might face at some point if you have your own shop. We got two shop spaces that we can rent. One of them is a rectangular shop that is 64 by 48. That one costs $4,800 a month to rent. The other shop is 52 by 44. That's a little bit smaller, but it's also a little bit cheaper. Let's figure out what the cost per square foot is for each shop to find out, based purely on that, what the better deal is. So let's start with this top one. We'll do this one in blue. We're dealing with a rectangular shop here, and it's 64 by 48. The symbol for feet is, of course, one tick mark. And so to find the area of that shop, we'll just take 64 by 48. I would encourage you, if you don't already have your calculator in your hand, or your phone for that matter, take it out and verify these calculations with me. 64 by 48, that means that this shop has an area of 3,072. Now, the measurement of area is always a square unit. In this case, it is square feet. To give you some perspective, 1 square foot is about the area of a typical floor tile. So we know that the shop's area is 3,072 square feet. Now we're paying $4,800 for that space. So the price per square foot, that's a unit rate. The price per square foot would be $4,800, and that's buying us 3,072 square feet, which means the price per square foot is about $1.56. You can verify that on your calculator or on your phone. I'd like you to take just a minute and do the same computation for the other slightly smaller shop. Pause the video, work that out, and unpause the video when you're ready to see the solution. Okay, that other shop is also a rectangle. It is 52 feet by 44 feet. And the area of this shop is 52 by 44, which is 2,288 square feet. So now, to find the cost per square foot here, we're paying $4,100. We're paying to get 2,288 square feet, and when you divided that out, you should get $1.79 per square foot. I didn't label my other one. That was $1.56 per square foot. And there we go. So the smaller shop is slightly more expensive. That doesn't necessarily mean it's a worse deal. It might be more energy efficient. It might be in a better location. But at least we have that information to compare. Curious thing, land, of course, when we measure land, we usually use acres to measure land, but take a look at this. This is a real website. You can go out there and take a look at it if you want, but it's pretty interesting because they offer, the website's right up there, by the way, but you can, for $49.99, buy 1 square foot. Again, that's just barely enough space to stand on if you put your feet together. 1 square foot, about the size of one of the tiles at the automotive center, for $49.99. And you can own that little piece of land and let sheep graze on it. Or You can buy 75 acres of land. This is near Bloomer, Wisconsin, for $189,000. So let's compare the price of these two. There's really not too much math to do on this one. It's $49.99 per square foot. So we want to find out what the cost per square foot of this land near Bloomer, Wisconsin is. So let's first of all figure out how many square feet you're getting. 75 acres, if you have your gold sheet, you can see your conversion fact on here. 75 acres, we'll put over 1. The conversion fact, this is on your gold sheet. If you don't have it, you can write this down on your formula sheet. That 1 acre is 43,560 square feet. Which means if you buy all 75 acres, you are getting 3,267,000 square feet. But you're paying a lot more money. You're paying $189,000. So the cost per square foot here, $189,000, gets you 3,267,000 square feet. And if you divide that out, it turns out to be about 6 cents per square foot. That's a pretty remarkable difference. 6 cents per square foot for this land near Bloomer, or $50 per square foot for this land in Ireland. So no surprise, this website is out to make some money. They didn't, whoever the owner of this land is, didn't pay anywhere near that much. They paid a fairly small amount, maybe not as cheap as the land in Bloomer, but definitely a money-making proposition for the Buy Ireland website. Okay, the second shape that we should explore is the area of a triangle. Area of a triangle is 1/2 base times height. One way to think about that is that if this were a rectangle, the area of that would be its length, this side here, which is the same as the base, times the width, which turns out to be the same as the height, but the triangle only occupies half the space in that rectangle. So if we throw out that space over there and we throw out that space over there, our triangle that's left is only half of the triangle space, and that's why we'll take the base times height and multiply it by half, or another way to say that is base times height over 2. Those are both equivalent forms for the area of a triangle. So finding the area here is pretty easy. The key is that whenever we decide what side the base is, the bottom, the height has got to be straight up to the peak. That's really the only critical thing to check. Now, which of the 3 measurements given here is the useless one? 18, 12, or 15? Well, 15 does us no good. That's the distance up one edge, and that doesn't help us. So our base is 18 inches, our height is 12. Our area would be base times height divided by 2 according to our formula. And so 18 inches by 12 inches divided by 2 gives us an area of 108. Make sure to include your units on that. That's 108 inches square. For the work that you send me, as well as your quizzes, daily skill checks that you'll be doing, in all this geometry unit, I'll be watching your units. That really tells me whether you know what you're finding or not. 108 square inches here. So here's a little problem we can work through. How many acres is this piece of land? This is popped right off of Google Earth. Take out your calculator and work through this with me. Let's figure out how many acres this piece of land is. So it's kind of a funny shaped parcel, but we can break it into a triangle up on top, a rectangle in the middle part, and then a little triangle down here in the bottom right. So start by finding the area of this rectangular part right in the middle. That's pretty straightforward. We can multiply 512 by 344. And that turns out to be 176,128 square feet. Okay, that takes care of that. Now let's go find the area of the triangle up on the top. The base of this triangle is 344 feet. We don't know the height of this triangle, but we can figure it out. the whole piece of land from bottom to the top, which is cut off a little bit up there. There's a peak to that triangle. We can subtract off this 512 feet. So the height of this triangle can be found by taking 923 minus the 512 feet tall that the rectangle is. 923 minus 512 leaves us with 411 feet. So that is 411 feet. So then the area of this triangle up here is going to be a base of 344 times a height of 411 divided by 2. That is 70,692 square feet, and that takes care of that. We'll add these all together at the end. And finally, we've got this little triangle over here on the right. We know what the height of this triangle is. The height here is 512 feet. We don't know what the width of this triangle is, though. But we do know that this whole thing is 487 feet wide and that 344 of it is the rectangle. So 487 minus 344, that'll leave us with the width of this triangle in the bottom, which is about 143 feet. So then we can find the area of this triangle down here by taking our base of 143 times our height of 512 and dividing that by 2. And that gives us an area down here of 36,608 square feet. Okay, so our total area is going to be the sum of all those. We started with 176,128 square feet in our rectangle. We added on that triangle on the top, which is 70,692 square feet. And then we also add that triangle in the bottom right, which is 36,608 square feet, which means the total area of this chunk of land is 283,428 square feet. Now here again we can convert that into acres, which is kind of the more useful measurement when it comes to land. So let's put that over 1, and there's 43,560 square feet for every acre, and that turns out to be very close to 6.5 acres. Now I'd like you to pause the video for a minute, take out your calculator and do this problem for practice. Got an air filter here, kind of an unusual shaped air filter. I would like you to find the total area. I'll let you think about how you can do that, but pause the video, do your calculation, and unpause when you're ready to see the solution. Okay, did you pause the video and work the problem, or are you just letting it play to see the solution? Don't do that. Stop the video, go ahead and get your calculator, and see if you can figure this out. Okay, let's work through it. There's two ways we could do this. We can either build this filter out of smaller pieces. We've got a big rectangle down here. There's a smaller rectangle up there, and then a triangle up here. You could do that. You could also build this thing by taking and treating the air filter as one giant rectangle, but subtract off this corner that's missing up here in the top right. And that's what we'll do because that's slightly simpler. So let's start with a big old rectangular filter that is 4 inches wide and 5 1/4 inches tall. If we do that, the area of that filter is 5 1/4 or 5.25 inches by 4 inches, and that gives us 21. Those would be square inches, okay? But we're missing a corner in the top right of that filter, so let's figure out what that area is and subtract it off. By subtraction, the top edge of this triangle that's missing must be the total width of 4 inches minus the 1.5 inches that's over there. So 4 minus 1.5 leaves us with 2.5 inches up here in the top right. Using the same kind of reasoning, this edge over here would be the 5 1/4 inch height of the filter minus the 3 inches on the right side, and 5 1/4 minus 3 leaves us with 2 1/4 inches for the height. And therefore, the area of that part that's missing, that area is 2.5 inches by 2.25 inches divided by 2, since it's a triangle, is equal to 2.8125, but we'll call it 2.81, that's close enough, square inches. And that's the part that's missing. So, to find the area of our filter, we'll subtract 21 square inches minus the 2.81 square inches that are missing, and that leaves you with 18.19 square inches for the area of the filter. Okay, our third shape is a parallelogram, and a parallelogram is kind of like two triangles. If you split a parallelogram from corner to corner, you get the area of a triangle. But there's another triangle right alongside of it that matches the first one, and so to find the area, we can take the base times the height and simply not divide it by 2. That'll give us the area of a parallelogram. Area of a parallelogram is base times height. Just like a triangle, we can let any side be the base, but then the height has to go straight up from it. It has to be straight up from the bottom. Usually the base is on the bottom side, and our height will be straight up from that. If you didn't already, you should write that formula as well as the one for a triangle and a rectangle on your formula sheet. And let's take a look at an example. Okay, this is a math teacher's dream, I gotta tell you, but this is an office building in Germany, and those are the approximate dimensions of this building. Now, let me ask you, which of these three dimensions is useless? Is the 75 useless, the 55, or the 98? Well, the 75 doesn't do us any good. That's called the slant height, the height up one edge. We would need that for the perimeter, but we don't need it for the area. So the base of this parallelogram is 98 feet. The height is 55 feet. This one's pretty straightforward. Our area will be base times height, which in this case is 98 by 55, and that is 5,390 square feet on the side of that building. We're done. Okay, and our fourth and final shape that I want you to be familiar with is a circle. To find the area of a circle, we need to know the radius of a circle. Now, keep in mind that the circumference of a circle was equal to pi times diameter. To find the distance around, we need the diameter, but to find the area, we use the radius. Order of operations says we have to square that radius first before we multiply it by pi. So the area of a circle is pi r squared. Make sure that one finds its way to your sheet. Again, we're going to use a pi value of 3.1416 or your pi button on your calculator. And that means when you're doing your work for today, your answers will be a little bit higher than those in the back of the book, and that's a good thing. So let's find the area of a piston whose diameter is 9.5 centimeters. So the diameter is the distance across, that is 9.5 centimeters. But of course, to find the area of a circle, area is equal to pi times your radius squared. We need to know the radius. Then it's pretty clear that our radius is going to be half of that. So 9.5 centimeters divided by 2, that gives us a radius of 4.75 centimeters. And therefore we can perform our computation. The area of this circle will be pi times 4.75 squared. Take your calculator. Don't just watch me do it. Take 4.75 and square that, and multiply that by our pi value, and that is 70.88 centimeters squared. Here again, Pay attention to your units. The units of centimeters squared are important. If you would have put, for example, just centimeters on there, that can't be an area. Centimeters would be the kind of units you have on a perimeter. Area will always be squared units. Okay, before we wrap this up, this is kind of an interesting problem. Let's determine the area and the perimeter of each of these shapes. Okay, again, take out your calculator. Let's start with the area of each of these two shapes. So for the one on the left, it's pretty clear we can break that into a rectangle and a semicircle or a half circle. The area of the rectangular part is going to be length times width, or in other words 38 inches by 30 inches, which means the area of this part is 1140 square inches. Do you agree with that? I hope so. Now, the area of the semicircle on the left side, we have to figure out what that diameter is. The whole thing is 38 inches. If we take 38 minus the 6 on the top and minus the 6 on the bottom, that leaves us with 26 inches. So that means that this distance right here is 26 inches. Now we want to find the area, so what we really need to know is the radius. The radius must be half of that, and so the radius of this semicircle must be 13 inches. Now, the area of this part over here, that's a circle, so our area would be pi times the radius squared, but it's only a half a circle, so we'll need to divide that by 2. So for our calculations, that's pi times 13 squared, but then we're going to divide that by 2. And that gives us an area of 265.47 square inches. So we can add those together and we can conclude that the total area of this entire shape, the rectangle and the circle combined, will be 265.47 plus 1140 square inches, and that gives us 1,405.47 square inches. That is the total area of that shape. Now the one on the right, there's not too much work to do, right? Because before we take that semicircle out, we know that the area of this is 1140 square inches because that's the same as it was over here. And we know that this semicircle, by all the same math, is 265.47 square inches. So then the area that's left, we won't be adding on that semicircle, we're going to be subtracting it off. And so our area here will be 1140 minus 265.47 is 874.53 square inches. That is the area of this one on the right. So very, very little work to do once we found the area. Now let's do that again, but this time let's find out what the perimeter of each of these two shapes is. So the perimeter is the distance all the way around. We know that that measurement is 6. We know the measurement across the top must be another 30 inches, just like the bottom. The right edge is 38, the left edge is 30, up there is another 6. The only real work here is to figure out how far it is around that arc or that semicircle. Now we already established from our work with area that the diameter here was 26 inches. And so the length of this arc will be pi times 26. That's if there was a whole circle here, which there's not. So we're going to divide that by 2. And so that leaves us with an arc length of 40.84 inches. Now we can find the perimeter of that. The perimeter, the distance all the way around the outside edge, is going to be 6 plus 30 plus 38 plus 30 plus 6 as we work our way around the outside, plus that 40.84 inches that we had on our last curve. and that gives us 150.84 inches for our perimeter. That's for the one on the left. Now let's do the one on the right. We know that that's also got 30 inches across the top, 38 inches down the right side, 30 inches across the bottom, 6 inches up, and this is also a semicircle. It must also be 26 inches along that arc. And so the perimeter here is going to be, sure enough, 150.84 inches. Even though this semicircle runs inside and the other one ran outside, the perimeter of these two shapes is the same. The areas are different as we saw, but the perimeter is the same. So I want you to recognize that even though the space inside is different, the distance around the outer edge is going to be exactly the same for both. Okay, last problem. I want you to do this one. I want you to tell me which of these two speedometers has the larger viewing area. The one on the left is a round speedometer that is 4.5 inches in diameter. Figure out what the area of that is. The one on the right is a semicircle only. It's only a half a circle, but its diameter is 6.5 inches. Find the area of each of those, and we'll compare them. Pause the video, work that, and unpause to see the solution. Okay, here we go. The one on the left has a diameter of 4.5 inches, and I think that you would agree then that it has a radius of half of that, or 2.25 inches. That means its area is pi times 2.25 inches squared, which is 15.90 square inches. There's the area of the one on the left. The one on the right, the area of that one is pi times, what's our radius here? Well, our radius for the one on the right must be half of 6.5 or 3.25 inches. So pi times 3.25 inches. But of course that one's only a half of a circle, so we need to divide that one by 2. And when you divide by 2, you get 16.59 square inches. So this one on the right, even though it's a half a circle, actually has a slightly larger viewing area. Okay, so that wraps up our work on area. Just to review, you should have and know the formula for the area of a circle, the area of a parallelogram, the area of a triangle, and the area of a rectangle. So as long as you can compute those areas, you should be in good shape as we move forward. The assignment will be given on Blackboard. Don't hesitate to reach out if you have questions.